Statistical methods investigating relationships, correlations, and regression. The goal of today's session is to understand and be able to explain what correlation is and when to use it, the rationale for the R value, the size of the correlation, 3 limitations of correlations, what a regression and multiple regression are and when to use them, what intercept and slope are, and how to interpret the results of correlation and regression analysis. First, let's talk about correlation. What is correlation? Correlation is a way of measuring the extent to which two variables are related. When correlation is positive, it means when one variable increases, the other variable increases too. For example, the more you smoke, the higher the risks of you getting lung cancer. When correlation is negative, it means when one variable increases, the other variable decreases. For example, the more you eat healthy, the lower the risks of getting heart disease. When there are no correlations, there is no systematic relationship between two variables. For example, your height and your intelligence have nothing to do with each other. Here is an example of a research question for correlation analysis. Is the number of likes you get on your Instagram per post related to your overall happiness? The statistics behind correlation is different from t-test or ANOVA. Correlation is a measure of the relationship between two variables, x and y. To calculate the correlation, we first need to estimate the covariance between x and y. Covariance is to what extent the scores on two variables change together. Covariance is calculated based on how scores of x and y differ from their respective means. Positive covariance means two variables tend to change to the same direction. Negative covariance means two variables tend to change to the opposite direction. So covariance can tell you the direction of the relationship between two variables. But what covariance still cannot tell you is the strength of the relationship between two variables. To estimate the strength of the relationship, you need to standardize the value of the covariance. This is because variable x and y have different units of measurement. For instance, likes on Instagram per post can vary from 0 to 100 or even to 1 million for a popular Instagrammer, whereas self-reported happiness can vary only from 1 to 5 or 1 to 7 because the scale is from 1 indicating not happy at all or 5 or 7 indicating very happy. So likes on Instagram and self-reported happiness have different units of measurement. The standardization of the covariance standardizes the units of measurement from two variables, and it makes the value always range from -1 to 1. You can do this by dividing the covariance by standard deviation of x and y variables. This standardized value of the covariance is the correlation, which can tell you not only the direction, but also the strength of the relationship between two variables. When R is close to 1 or -1, it means there is a perfect linear relationship between two variables. When R is 0, it means there is no relationship between two variables. Here's how you would report the results of correlational analysis. There is a significant and positive relation between the number of likes on Instagram and happiness of the Instagrammer. Make sure to include the value of R and the value of P, which indicates whether R is significant or not. If p-value is smaller than 0.05, there is a significant relationship between variables A and B. Correlation size depends on the value of R. When R is between 0.1 and 0.3, it indicates a small correlation. When the value is 0.3 to 0.5, it indicates a medium-sized correlation. When R is larger than 0.5, it indicates a large-sized correlation. There are a few limitations about correlation analysis. One is the direction of causality. Unlike the t-test or ANOVA, correlation is not a measure of the effect of one variable on another. It is a measure of the relationship between the variables. It can tell you to what direction two variables change together and how strong the relationship between two variables is. But it cannot tell you which variable causes which. With correlation analysis, we can only conclude that the more likes people receive on their Instagram, the happier they are. We cannot say anything about the cause and effect of the relationship. For example, we cannot assume that people are happier because they receive more likes on Instagram, or people receive more likes on Instagram because they are happier. Another limitation of the correlation analysis is the third variable problem. For example, let's imagine that we found a positive correlation between ice cream consumption and the crime rate. However, there is no scientific evidence that the more ice cream people eat, the more aggressive they become. So why do these variables seem to be related when they aren't really? This is because of the third variable, heat, which influences both ice cream consumption and the crime rate. In other words, the variable heat confounds the relationship between ice cream consumption and the crime rate. When the weather is hot, people tend to eat more ice cream. But at the same time, heat makes people get irritated and become more aggressive. So the correlation between ice cream consumption and the crime rate is due to the influence of the variable heat on both variables. Statistical analyses are important, but the number can be misleading sometimes. Only with the good theories and literature review, which explain why those variables should be related, your numbers become meaningful and valid. In the case of an example, likes on Instagram and happiness, a possible third variable is physical attractiveness of Instagrammers, meaning how pretty or how handsome those Instagrammers are. In psychology, there is a tendency for attractive people to be more liked and better treated by other people. This is called a beauty bias. Due to the beauty bias, it is possible that the more attractive the Instagrammer is, the more likes on Instagram she or he may get because of their popularity, and at the same time, the more attractive the Instagrammer is, the happier he or she may be because they are better treated in your society. If attractiveness is significantly correlated with both likes on Instagram and happiness, that means there is a third variable problem, and attractiveness confounds the relationship between likes on Instagram and happiness. If attractiveness is significantly correlated with only one of the two variables or none of them, there is no third variable problem. Next, let's talk about regression. What is regression? Like correlation, regression is also a test of the relationship between variables. But with regression, you can make a hypothesis about which variable is predicting the relationship. For example, with regression, you can say a number of likes on Instagram predict happiness, or happiness predicts the number of likes on Instagram. It is a way of predicting the value of one variable from another. So the research question would be, does the number of likes you get on Instagram post predict your overall happiness? A linear regression is calculated based on the equation of outcome equals the model plus error. A score on a dependent variable y can be described as an intercept beta 0 plus slope beta 1 plus error. Let me explain what intercept and slope really mean. Let's look at the graph on the left. Vertical axis represents the scores on the dependent variable or the outcome, and horizontal axis represents the scores on the independent variable or the predictor. The red line indicates a positive relationship between the predictor and outcome because every time a score of the predictor increases, a score of the outcome also increases. The green line indicates a negative relationship between the predictor and the outcome because every time score of the predictor increases, a score of the outcome decreases. Intercept is the point at which the line crosses the vertical axis, basically the starting point of the regression line. Slope indicates the state of predicted change in y given one unit of change in x, showing how much y is predicted to change every time x changes by one score. In this graph, both red line and green line have the same intercept but different slopes. Now let's look at the graph on the right. Here all three lines have different intercepts, but they have the same slopes. Because three lines begin from different points on the y-axis, but have the same degree of change in y as x changes, as three lines are parallel to each other. With intercepts and slopes, we can test to what extent your independent variable predict your dependent variable in your hypothetical model. This is how you will report your regression results. You first describe whether your independent variable predicts your dependent variable or not. For example, likes on Instagram per post did not significantly predict happiness. Then you provide a standardized regression coefficients beta and its standard error and whether p-value is significant or not. The beta indicates the strength of the relationship between the variables or the prediction of one variable over another. And p-value indicates whether beta is statistically significant or not. You will typically also report R-squared by indicating how much variability of your dependent variable was explained by your model. In this case, 12.30% of the variability in happiness was explained by the model. Now let's talk about multiple regression. A research question of multiple regression is one outcome variable and more than one predictor. For instance, we can investigate whether the number of likes on Instagram and attractiveness predict overall happiness together. Multiple regression sounds fancy, but it is actually just a normal regression model with more than one predictor. The regression equation looks a bit more complicated because it is longer, but it is longer because we now have more than one predictor or more than one slope. But other than the number of predictors, multiple regression is no different from the normal linear regression. To report the results of multiple regression, first describe whether your independent variable predicts your dependent variable or not. For instance, both attractiveness and likes on Instagram did not significantly predict happiness. You also provide a value for standardized regression coefficients beta, standard error, and p-value. Do not forget to also mention R-squared, which indicates how much variability is explained by the model. That's it for today. Please do learning by explaining by next week. Please explain to your friend what you have learned today. What are the important key concepts? What are the examples of those concepts? What are the connections between those concepts? What did you find interesting? Was there anything that was unclear or difficult to understand? Were there any questions you would like to ask I? Try to come up with your own examples of correlation, regression, and multiple regression analysis. Thank you for your attention and see you next week. Goodbye.